This is a circuit for an NPN transistor based signal amplifier. We're using PV1 as the output voltage source and we're setting it to 5 volts, and A2 will monitor the output. PV2 provides the bias, and as you can see, when the bias is just the right amount is where you can get the amplification of the signal. And the actual signal comes from WG, which is a sine wave generator. And we're dividing the amplitude of the sine wave, we're making it very small to the order of around 4 millivolts using a 100 ohm resistor across the divider pins you find on the C-Lab device. Let's configure the trigger of the oscilloscope to use the second channel, which is A2, the red trace, and set it to an appropriate level. Now we can drag and select a region to perform a sine fit. And you can see that the output amplitude is around 2.18 volts while the input was 4.36 millivolts. So that's about 500 times of gain. And as with every experiment, there are some instructions in the help tab. I'll now put this circuit to a little bit more practical use, where instead of the sine wave generator, I'm going to use a small condenser microphone. So what I've essentially done is that instead of using the 1 microfarad and the sine wave generator, I've taken a condenser microphone, placed it in place of the 1 microfarad, and instead of connecting the wire to WG, I've connected it to CS1, which is a 3.3 volt source, which will be used as the bias for the mic. Now the signal from the mic is going to fall on the base. First we'll need to readjust PV2 such that the signal will stay between the 0 and 5 volt amplitude, and as you can already see, as I'm talking into the microphone, the signals are picked up. So if I whistle with a constant frequency, let's say, I can actually take a sine fit and find out that the frequency is around 1750 Hertz.